At its core, two things are required for programming with RFEM 6 and Python, that is, RFEM 6 and Python. The first thing that we want to do is ensure that web services is enabled in RFEM 6. To do this, launch your RFEM 6. On the top navigation bar, go to Options, Program Options, and make sure that Start the Server automatically with the application under the header Web Services is enabled. Click Apply or OK. As additional information, you will notice that when clicking on Web Service Panel, a server port range appears top right. This has got to do with the communication through the SOAP protocol and the HTTP medium. RFEM 6 as an application occupies the 8081 port, where subsequent models within RFEM 6 occupies ports 8082 and onwards. With that covered, we can now move to the second requirement, that being Python. Important to understand is that it's not a specific program or application, but rather a language, meaning there are many ways that we can write and execute Python code. For example, I can launch Python from my command prompt simply by typing in Python. Now I can execute commands such as the famous print hello world, or declare variables such as a is equal to 2, b is equal to 1, and complete mathematical operations on these variables. There is also idle, which comes installed on most PCs. In the terminal window now we can execute the same code as before. However, immediately we will see a difference with idle, and that's within the print command there is some help on what arguments to provide in the function. Furthermore, it colors portions of the text differently depending on criteria such as a function in purple, a string in green. These features are characteristic of what we call an IDE, which stands for Integrated Development Environment. At this stage, I'd like to introduce Visual Studio Code, which is a type of IDE. If I start a new Python file, we can run through some core features of what an IDE looks like. The area in which we type code is called the text editor. In here we can write commands as before. IDEs such as Visual Studio Code offer extra support for your programming projects such as code completion, help functions, graphical realization, debugging tools, as well as a connection to GitHub, which can be very useful. Illustrating the ease of use, I simply type PR and tab onto the print function with the help of code completion. Using a powerful IDE like Visual Studio Code is therefore highly recommended. Other IDEs such as PyCharm, Spider and PyDev exist. The choice is ultimately yours. If you're unsure and would like to follow along as comfortably as possible, we recommend using Visual Studio Code for these videos. It is free to download and a link is provided in the description of this video. With the programming environment covered, the final ingredient needed before we are ready to start programming with RFEM 6 is the aforementioned Python high-level function library. All objects in RFEM 6 are accessible through the library. That includes and is not limited to geometrical definition and data, loads, supports, results. The library is stored in our Dlubal repository on GitHub. For those who are not aware of what GitHub is, it is in short a version management system. And since we are continually bettering the library, a dynamic file access through GitHub is very practical. To access the repository, navigate to it using the link. You have two options to access the repository, either by cloning it or downloading it statically. If you are an experienced GitHub user with an account, we recommend cloning. If you do not have a GitHub account, you can download the repository statically as a zip file. Benefits of cloning the repository is the ability to receive updates as we continue with development, which could be in the form of adding new features and example codes, etc. With a clone of the repository, we are now ready to start programming with RFEM 6 and Python. But before we go on with the first example, we will run through the concept of a library in Python with an emphasis on the RFEM 6 high-level functions library, which we have just cloned to our computer. This is the subject of the next video.